Hello students, so let's start to solve the exercise. First exercise of the complex number. The first question is expressed in the form of the a plus iota v, and a plus iota v is the complex number. First question is 5 iota in bracket and minus 3 upon 5 iota in next bracket. Bracket means multiplication. So we will multiply both the terms, 5 in numerator and 5 in denominator. They can cancel out with each other. Minus 3 iota multiplied by iota is equals to minus square, iota raised to power square, and then I will replace the value of the iota square, which is equals to minus 1, and minus 3 minus 1 is equals to 3. So given result can be expressed in the form of the a plus iota b. How? First I will write z is equals to, z is a complex number, z is equals to 3. So if z is equals to 3, then I have to write the imaginary part also, reason being 3 is the real part without iota, and I have to write the imaginary part also. So I can write it as a 0 iota. So real part is 3 and imaginary part is 0 here. So next question is iota raised to power 9 and iota raised to power 19. As in the previous class, we have discussed something about the power. As you can see, the multiple of the 4 will give me result 1, and multiple of the 4 with remainder 1 will give me iota, and multiple of the 4 with remainder 2 will give me minus 1, with remainder 3 will give me result minus iota. So we will use these results in these questions. So iota raised to power 9 is not a multiple of the 4, so we will make it multiple of the 4. How? Iota raised to power 4 multiply iota raised to power 4 and rest iota raised to power 1. So it will give me the result 1. It will also give me the result 1 and iota as it is. Iota raised to power 19. 19 is not a multiple of the 4. So which number is a multiple of the 4? 16, right? So I can write it 16, and next is 3. 3 is remainder. So if 3 is remainder, what will be the result? The result is minus iota. I will replace the value. So from here I am getting iota, and here minus iota. Iota positive and iota negative give me result 0. I will express it and in the complex form. Z is equals to 0. I can write it like this: 0 plus iota 0. So a0, real part is 0 and imaginary part is also equals to 0. In the next question, I have given iota raised to power minus 39. And 39 is not the multiple of the 4. I will make it multiple of the 4. But before that, first I will remove minus sign. How I will remove? I will bring it in the denominator. Iota raised to power 39. It will become positive, and I will bring it in the denominator as it is in the denominator. So I will convert it into the 4 multiple power. So how? I need one more iota here. I will multiply, rationalize with the iota in numerator and iota in denominator. So I will get iota raised to power 40 in the denominator also, and 40 is a multiple of the 4, of course. So if the 40 is the multiple of the 4 without any remainder, so it will give me the result 1, and iota as it is, the result is iota. I will convert it into the complex form again. How? I have imaginary part but real part is missing, so I can write 0 in the imaginary part. So in this way we can solve this type of the question. So you can see in the question number 4, there are 2 brackets. So for the 2 brackets, I will multiply 3 inside this bracket and iota in this bracket. So I will multiply 3 first with the real part, then with the imaginary part. 21 iota, and iota into 7 is 7 iota. Iota multiply with the iota, and what is the coefficient of iota here is 1. So real part will multiply with the real, and iota with multiply with the iota. So 1 multiplied by 7 is 7, and iota multiplied by iota is equals to iota square. Iota square, and you know what is the value stand for the iota? Iota square is equals to minus 1. Iota square is equals to minus 1. I will replace the value 21 as it is, and from here I will put the -1. 7 multiplied by -1 is equals to -7. So iota 21 plus 7 iota. In the previous classes, as we add the x literal with the x literal and y literal with the y literal, in the same sense we will add here iota term with the iota term. Iota here is as a literal, it will work like a literal as it is a complex number. So we will add imaginary part with the imaginary and the real part with the real. So this term will become the real as iota has eliminated here. So 21 plus 7, it will become 28 iota. It is a imaginary term and this will make the real term. So again I have expressed like this in the form of the complex number. In the fifth question, we have two brackets. I have to subtract them. The sign of subtraction is there. So we will simply subtract, but before that we have to open the bracket. If the negative sign is outside the bracket, we will change the inside sign of the terms. So 1, minus iota, minus into minus plus, minus into plus, minus. So I am getting here, and I will add real with real and imaginary with imaginary. So in this sense I can get this a as a real and result for the b, that is -6. So you can see here, if I'm expressing it as a plus iota b, the standard form is a plus positive sign, but in the result I have negative sign. So I have to bring this negative sign with the imaginary part, that is the 6. So I will bring it with the 6, -6. So don't mistake here. Usually students mistake in their exams. So this bracket, I have to subtract it. So what I will do, I will first remove the bracket according to the BODMAS and multiply this sign of my minus inside the bracket. It will change the sign of the terms, and then real with the real and imaginary with the imaginary. So let's move. So this is the next step. You can see I have taken the, because it is the fractional terms p by q form, so I will make the LCM to solve it. Real, this is a real term and this is the imaginary term. How I will add it, I will take the LCM and I will solve. So 5 is the LCM here, and in this 10 is the LCM. So in this sense I'm getting this result, and I will subtract here and here. I'm getting 19 by 5 and -21 iota upon 10. So I will express in the complex number again. I will write it as a z is equals to -19 by 5 and -21 iota by 10. So expressed in the complex form, that is a plus iota v. So the value which is real is the -19 by 5 and the b is -21 by 10. So this was a result. And in the question number 7th, you can see we have 3 brackets. First we will add 2 bracket inside this square bracket, and then after getting a single result from this square bracket, I will use this third bracket. But first I have to solve this bracket, square bracket. So in this bracket, it is only simply a positive sign is there, so no need to change the sign inside a bracket of the second bracket. So I will add real with real and imaginary with imaginary. So I'm getting 1.3 plus 4. I have write 4 in the p by q form. As to simplify and to better understanding, for the better understanding, I'm writing 1 in the denominator so that I can take the LCM of 3 and 1. It is 3, and 3 in 3, 3. So I'm getting this. You can see 5.3, and from the imaginary part, I'm getting 7, and coefficient of the iota is 1. So I have to add coefficient. 7 plus 1 is 8, and iota have to write one time. Reason, 3x. For example, 3x plus 4x is equals to 7x, right? In the same way, I'm adding here. Literals. Take the ones. So I will use now third bracket. But now the negative sign is there outside the bracket. I will change the sign inside the bracket. So it will become negative. It will also become negative, and then I will add real with real and imaginary with imaginary. In this sense, I'm getting the result. And after getting the result, I will express in the complex form exactly. A plus iota b a plus iota b. A is a real part and b is the imaginary part, right? So in this way I'm expressing it. Next very important question, it is usually come in the exams. It is power 4. 1 plus iota raised to power 4. So how I will solve it? I don't know how to use the formula for the 4. So I will convert it into the power of 2, because I know the better formula for the power 2, because a plus b or a minus b whole square is equals to a square. A minus b whole square is equals to a square plus b square minus 2ab. So it is a simple formula which I will use in this question. Instead of the solving the power 4, I will choose the power 2. And 4 power, I can write it as a 2 multiplied by 2, because bracket means multiplication. So 2 multiplied by 2 will become again 4. So I'm writing it like this. This is the a, this is the b, as we will see the formula. So a minus b whole square is equals to a square b square minus 2ab, right? So I will simplify it. Iota as it is, iota square is minus 1, and I'm using this square only. So this is left. I will copy it as it is, like so. I'm getting minus 2 iota raised to power 2. So if the power 2 is outside the bracket, then don't mistake here, because minus also have the sign, also have the power 2, 2 also have the power 2, iota also have the power 2. So all three things inside the bracket having the power 2. So one by one we will have to simplify. Minus raised to power square, minus square is equals to positive, 2 square is equals to 4, and iota square is equals to iota square. We will replace the value of the iota square here, minus 1, exactly. So 4 multiplied by minus 1 will become minus 4, and this is the result. I have to express it in the complex form. Minus 4, imaginary part is absent here, so I will write it like iota 0. Therefore a become minus 4 and b become 0. In the question number 9th, the formula is cube. So I will solve this question using the formula simple: a plus b whole cube. A plus b whole cube. So what is the formula stand for that? A cube b cube, 3a square b plus 3ab square. So I have expressed given question in the form of this, and I will choose this formula now. A cube b cube. What is a? A is 1 upon 3. This is working like a, and this is working like a b, right? So a cube b cube plus 3a square b plus 3a b square. So I will simplify these powers. 1 cube is 1, 3 cube is 27, 3 cube is 27, and iota cube is minus iota, exactly. If you remember this 3's remainder, the result is minus iota. So minus iota here, and just simplify it properly. 1 square is 1, and 3 multiplied by 1 multiplied by 3. So it will become 3 into 3, 9. So 3 square is 9, of course. Iota as it is, I will cancel out 9 with 9. And here 3 square is 9, exactly. 9 multiplied by this 3 is 27. 27 multiplied by 1 is 27, exactly. But in the denominator 3 is there, right? So I will cancel out with each other, and iota square also is there, because iota also having the square. So iota square is equals to minus 1. I will replace the value for the iota square, and I will multiply with this 9. So in this way I'm getting minus 27 iota, and iota minus 9. This is the fractional, this is not having fractional. I can write it like denominator as 1, denominator as 1, real with real, and imaginary with imaginary. I will add now. So this is the way to add by taking the LCM. and 27 multiply by 9 because LCM is 27. So 226 iota. I'm getting minus 242 divided by 27 minus 26 iota. I will express it in the form of the complex number. So this was your 9th question. In 10th question is absolutely similar like 9th question. So you can also simplify with yourself. You can see I have simplified this question similarly as in the 9th question, right? So next question is multiplicative inverse.